In this lesson, we are going to look at how to calculate the molecular formula given the empirical formula, and also how we can find the molecular formula given the percentage for a compound and its relative molecular mass. So now, the definition for molecular formula is a formula which shows the actual number of each kind of atom in the compound. So the formula is, if we want to find now molecular formula, so is equal to empirical formula. Then multiply by n, where n can be found by dividing relative empirical formula mass into relative molecular mass. So here we have relative molecular mass over relative empirical formula mass. So we can say relative empirical formula mass. Okay, now let's have the example. Okay, so now here the example is the empirical formula of a compound is C2H4, or its relative molecular mass is 88. Find the molecular formula. So now the molecular formula MF is equal to empirical formula multiplied by n. So we are going to begin by finding the value of n. The formula for the value of n is equal to relative molecular mass over relative empirical formula mass. So the relative empirical formula mass is now the mass, the mixture that we are going to find from the empirical formula. So the empirical formula is C2H4OH. So we are going to find a mixture, and this mixture for empirical formula is what we call the relative empirical formula mass. So here we can see that we have 2 atoms of carbon plus 4 atoms of hydrogen plus 1 atom of oxygen. The mass number for carbon is 12 times 2, plus here we have 1 times 4 plus 16 times 1. 12 times 2 is 24, plus 1 times 4 is 4. 16 times 1, that is 16. 24 plus 16 is 40, plus 4, that is 44. So the relative empirical formula is 44. So now we can proceed, we can go back to now find the value of n. So the relative molecular formula we have been given is 88 over the relative empirical formula we have calculated, that is 44. So 44 into 88 is 2. So the value of n is 2. So now we go back to our formula. So the empirical formula is C2H4. Then for oxygen there is only 1 since the number is not shown. Then where there is n here we put 2. So these 2 will multiply with the subscript here. So we can now see, we can now multiply 2 times 2. So we have C4, 4 times 2, this our 8, 2 times 1, that is 2. So this is now our molecular formula. Then if we have been given, let's say, molecular formula, and the question is if we want to find the empirical formula where the value of n is given, let's say the value of n is equal to 2, and the molecular formula is C4H8O2. So if you want to find the empirical formula, you now divide. So you divide by 2. So 2 into 4 is 2. 2 into 8, that is 4. 2 into 2, that is 1. So if you are looking for empirical formula given the molecular formula and the value of n, you divide. Then if you are looking for molecular formula given the value of n and the empirical formula, you multiply by the value of n. Okay, let's have another example. Okay, so now we have the question: a compound of carbon has a composition of 15.8% carbon and 84.2% of sulfur. Find the empirical formula and the molecular formula if its relative molecular mass is 76. So we have two questions here. The first question, we are going to find the empirical formula. Then the second one, we need to look at the molecular formula. So let's first begin by trying to add the percentage, the given percentage. You have to make sure that the given percentage must add up to 100%. So if the percentage is less than 100, meaning there should be another element that is missing. So let's say we have 15.8%, then plus 84.2. So you can see we have 10, which is 0. 5 plus here plus 1, that is 0. Then we can see that the percentage is adding up to 100. So that is the first step that you need to do. Make sure the given percentage is adding up to 100. Now after we are done with proving the percentage, let's now move on. So we have two atoms here. There is carbon and there is also sulfur. So we can now say we have carbon, then and sulfur. So now the percentage for carbon is 15.8%. For sulfur is 84.2%. So now after you've written the percentage for each element, we need to divide by its molar mass. So the molar mass or the relative atomic mass for carbon is 12. So we divide by 12. Then also we need to divide by the molar mass for sulfur. And the molar mass for sulfur is 32, or the mass number for sulfur is 32. Then if we divide the 12 into 15.8, we have a value about 1.317%. Then here, if we divide 32 into 84.2, we have the value about 2.631. So now after you are done dividing the given percentage by its molar mass, we need to look at the two values. So we are going to divide the two values by the lowest number. So you can see that 1.317 is lower than 2.631. So we divide by each side by 1.317%. Also here 1.317, and so that we cancel. So 1.317 into 1.317 is just 1. Then if we divide now 1.317 into 2.631, so this we get 2. So what this means is since 1 is in line with carbon, there is 1 atom of carbon and there are 2 atoms of sulfur. So the empirical formula, we have C1, then S2. So this is now our empirical formula. Now the other question that we have, we need to find the molecular formula. So the formula, we say the molecular formula is equal to empirical formula multiplied by N. So let's find the value of N. N is equal to relative molecular mass over relative empirical formula mass. So let's find the mixture for, so you can see that we have 1 carbon, so carbon times 1 plus sulfur times 2, 12 times 1 plus 32 times 2. So 12 times 1 is 12 plus 32 times 2, that is 64. So 12 plus 64 is 76. So we can now say N is equal to, the relative molecular mass is given 76 over the relative empirical formula is also 76. So 76 into 76, we can see that we have 1. So in a case where the value of N is equal to 1, the empirical formula will be the same as the molecular formula, because anything times 1 is just the same. So molecular formula is equal to CS2, then 1. So we know that if we multiply by 1 here, we are going to have CS2. So this is how you can answer a question like this one. Okay, now let's do the last question. A compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Find the empirical formula. That is our first part. So the empirical formula. So we can see that we have been given percentage. Let's check now our percent. So we have 40 plus 6.7% plus 53.3%. So we need to check the percentage adds up to 100. Okay, so when you add 40 plus 6.7 plus 53.7, you are going to get 100. So we can now proceed. So after verifying this, we need now to write each element. So the first element is carbon. The second, we have hydrogen. The third one is oxygen. So we are going to write each with its percentage. So the percentage for the given percentage for carbon is 40. The hydrogen is 6.7%. For oxygen, we have 53.3%. So now after this, we are going to divide each element by its molar mass. So the molar mass, the mass number for carbon is 12, mass number for hydrogen is 1, mass number for oxygen is 16. So 40 divided by 12, we get 3.3333. We are very carrying. Then 6 divided by 1 is 6.7%. Now let's check our oxygen. 53.3 divided by 16, we get 3.3333125. So from here we can see that the lowest number is this one for oxygen, because we can see after the decimal, the number on the fourth position is 1, but we can see that here we have a 3, so this is the less number, so we divide with the lower number. So we divide with the lowest number, 3.333,125% even here. So we know that this will give us 6.7 divided by 3.33125. We have 2.010, so we can just say 2, just round it off to the whole number. Then we go to this one. So I'm getting about 1.00, which is 1. So from there we can see that there is 1 carbon, 2 hydrogen, and 1 oxygen. So that is our empirical formula. So now after finding the empirical formula, let's go to question B. Question B, if the relative molecular mass of the compound is 180, work out its molecular formula. So the formula we said molecular formula is equal to empirical formula multiplied by n. Then we need to find the value of n. So the value of n we said is equal to relative molecular mass of the given compound divided by relative empirical molecular mass. So let's find the relative empirical molecular mass. So here we can say Mr is equal to, there is 1 carbon plus 2 hydrogens plus 1 oxygen. Here we have 12 times 1, 1 times 2. So 12 times 1 is 12 plus 2 plus 16 times 1 is 16. So 16 plus 2, that is 18 plus 12, we get our 30. So you can see that the relative empirical molecular formula is 30. So n is equal, now where there is the relative molecular mass, we substitute with 180 over 30. So n is equal to, you can cancel this, 3 into 18 is 6. So molecular formula is equal to the empirical formula CH2O times 61. So this will multiply with everything, so C6. Here we get 12 or 6. So this is how you can find the molecular formula and the empirical formula given the percentage of elements in a given compound. That's it for this video. Thanks for watching.